Hi everyone, welcome to my channel. Rocky planets may only get moons from one source, giant impacts. The giant impact hypothesis states that a Mars-sized body collided with early Earth, with the debris that doesn't fall back to Earth forming the moon. The Earth and moon, as a result, should be younger than the remainder of the solar system. It is possible that all rocky planets with large moons acquire them in this fashion. Out of all the rocky planets in our solar system, Earth is unique for many reasons, including liquid water on its surface, an active core generating a strong magnetic field, and the presence and abundance of life. But astronomically, the most glaring feature of our world is the large companion world we have just 380,000 kilometers away, our moon. Mercury has no moons, Venus has no moons, Earth has the one giant one, Mars is two tiny, asteroid-sized moons. For a long time, we had massive amounts of uncertainty surrounding the origins of our moon. It was only by traveling to the lunar surface and analyzing the composition of the moon itself that we discovered something incredible. The moon is made of the same material that Earth is. They must have had a common origin, and the moon's surface was once molten. A giant impact is thought to be responsible, and that may be the only way that rocky planets get their moons. When two bodies crash into one another in space, the resulting collision can be catastrophic for one or both of them. If the bodies are large enough to start with, however, they will create debris from a collision that will fall back to the combined planet, with the remainder coalescing into one or more moons. Imagine the solar system as it might have been in its earliest stages, a central, newly forming star surrounded by a protoplanetary disk. The star heats up, working to evaporate the material surrounding it, while gravitation works to pull matter in the disk into larger and larger clumps. It quickly becomes a race, as over perhaps tens of millions of years, protoplanets form while the central star boils away the material that hasn't clumped together fast enough. Asteroids and planetesimals in the early solar system were more numerous, and cratering was catastrophic. Once the protoplanetary disk and the surrounding protostellar material is evaporated away, the growth of the solar system's overall mass ceases, and it can only decrease from that point on. What you wind up with is a few surefire survivors, large, massive planets capable of holding on to a hydrogen and helium-rich gas envelope, surrounded by moons and rings, its own mini-planetary system. You also get smaller, less decisive victors, the rocky and icy objects that become planets and dwarf planets. The only problem is that there are lots of them, some of which share orbits, and they interact, eject each other, and collide. The evidence that Earth's moon was formed by a giant impact is overwhelming, and comes from many, varied lines of evidence. The Earth's spin and the moon's orbit around Earth have similar orientations. The moon has an iron core, just like Earth, except it's very small. The stable isotope ratios for the Earth and moon are identical, while they differ between all the other planets of the solar system. These all point to a common origin, consistent with a giant impact. A massive collision of large objects in space can cause the larger one to kick up large amounts of debris, which can then coalesce into multiple large objects, such as moons, that remain close to the parent body. An early collision like this likely created the moon, which has been slowing Earth's rotation and migrating away from our world ever since. But what's only recently come to light, as we've visited other rocky and icy systems that contain moons as well, is that the more we study them, the more their moons appear to have formed by giant impacts as well. It's a bit of a puzzle, because it doesn't need to be that way. A planetary collision in the early stages of forming a solar system could be a way to create a double planet, even potentially a pair of giant worlds. Any moons beyond them both would orbit rapidly, but would also tumble due to their mutual gravitational effects. The moons around planets we see today, however, do not appear to have resulted from such a scenario. Every large mass has a correspondingly large gravitational well, meaning that objects can have close encounters with it and get captured. Many moons of the gas giants are captured asteroids or Kuiper belt objects, from Saturn's dark moon Phoebe to Neptune's enormous Triton. Moons form at a great variety of distances away from the gas giants, and show a similar segregation of elements and isotopes the farther out you go. And as far as the giant planets go, their moons are much smaller than the major planet itself. The large moons of the solar system is compared with Earth in size. Mars is approximately the same size as Jupiter's Ganymede. Note that pretty much all of these worlds would become planets under the geophysical definition alone, but that only Earth's moon is comparable in size to its parent planet, the large moons of the gas giants pale in comparison. Yet this doesn't seem to be universal at all. In fact, something appears to be fundamentally different between the gas giants and the rocky worlds in terms of their satellites. Captured asteroids and protoplanetary disk scenarios cannot explain the moons we observe. Not for Earth, not for Mars, not for Pluto. When it comes to Pluto, it's been known for a long time that Charon, its giant moon, is so massive that the Pluto-Charon system is better classified as a binary system than as an object with a moon. The center of mass lies between the two worlds, well outside of Pluto itself. They have a close orbit, they're tidally locked, they're made of the same materials, but Pluto has practically all of the atmosphere. This image, taken by NASA's Hubble Space Telescope, shows all 5 moons of Pluto in orbit around this dwarf planet. The orbital paths are added by hand, but occur in a 1, 3, 4, 5, 6 resonance, and all orbit in the same plane to within 1 degree. The outer 4 moons, beyond Charon, all tumble instead of rotating on a consistent axis. A large collision could easily account for this, while an in-situ formation scenario cannot, nor can a captured object scenario. The tough part was the prediction that a number of smaller, outer moons should also form if Pluto and Charon resulted from a giant impact. The discoveries of Styx, Nix, Kerberos, and Hydra, and the facts that they're in the same plane, have resonant orbits at 2 to 4 times the Pluto-Charon distance, and large angular momenta, lends great weight to the giant impact scenario. Rather than the 2 moons we see today, a collision followed by a circumplanetary disk may have given rise to 3 moons of Mars, where only 2 survive today. Mars, at first glance, appears different. Its 2 moons, Phobos and Deimos, appear to be the size of asteroids. But Phobos and Deimos don't behave like captured asteroids would. They orbit in the same plane as each other, they co-orbit Mars consistent with the rest of the solar system, their orbits are circular and prograde, and they have similar elemental compositions and densities. The biggest problem with the giant impact scenario for Mars moons is that you can only get 2 small moons, in simulations, if you also get a third, large, in the moon. A brilliant paper from 2016, however, showed that a large, transient, interior moon is extremely consistent with Mars and its moons, assuming that it fell back to Mars a long time ago. The giant impact scenario, for Mars, Earth, and Pluto, is the leading idea for how these worlds got their moons at all. A large impact from an asteroid billions of years ago may have created the moons of Mars, including an inner, larger one that no longer exists today. Illustration by Media Lab. ESA 2001 Mercury is battle-scarred on its surface, but has no moons of its own. Venus should get impacted just as often as Earth did in the early stages of the solar system, but for some reason, perhaps due to its atmosphere or just the history of how it evolved, it doesn't have a moon, either. Many asteroids, Kuiper belt objects, and minor planets in general possess moons, with tidal disruptions of loosely held matter and collisions thought to be the major factors in their creation. In fact, of all the major bodies that are known to have satellites, including Haumea, Makemake, AMT Aurorus, their sizes and orbital parameters are incredibly consistent with having been created by collisions. If your gravity rises up to a point where you can pull yourself into hydrostatic equilibrium, a sphere if you're static, an ellipsoid if you're rotating, you cannot be pulled apart by tidal forces so easily. But you could, in principle, develop moons through 3 methods: initial formation from a protoplanetary disk, capturing another passing body through gravitational forces, or from the debris of a large collision. While the gas giants display moons that appear to have arisen from all 3, the rocky planets, including both major and minor planets, appear to obtain moons from collisions alone. It may be the case that the other options are viable but rare, and we simply have yet to discover them. But following the evidence we have today, perhaps Earth's moon isn't atypical after all. Until further notice, giant impacts are the only known way for rocky planets to gain moons. Please save the trees and nature, please subscribe my channel, thank you.